Deep beneath Antarctica's frozen surface, scientists have uncovered a secret that is as astonishing as it is consequential. This discovery is rewriting our understanding of the continent, challenging long-held beliefs about what lies below the world's coldest and most remote landmass. For decades, Antarctica was thought to be geologically quiet, a vast frozen expanse seemingly untouched by the forces that shape other continents. But new evidence reveals a powerful geothermal engine at work beneath the ice, radiating heat from deep within the Earth's crust. This hidden heat source is melting the base of the ice sheet, creating rivers of water that lubricate the ice above. As a result, glaciers can move faster and more unpredictably, fundamentally changing how we understand their behavior and how quickly sea levels could rise. The discovery forces us to see Antarctica not just as a passive victim of climate change, but as a dynamic system with its own internal drivers, an active participant in the planet's evolving story. The geothermal heat acts as a lubricant, making it easier for massive glaciers to slide into the ocean, sometimes with little warning. This changes everything we thought we knew about the stability of the West Antarctic ice sheet, raising new concerns about its vulnerability and the potential for rapid ice loss. Scientists now face urgent questions about how this internal warmth will accelerate ice loss, and what it means for coastal communities around the world. The fiery secret beneath the ice is a stark reminder that our planet's most remote places still hold surprises that can shape our future in ways we are only beginning to understand. Understanding this hidden energy is now a top priority for researchers worldwide, as they race to unlock the mysteries beneath the ice and protect our planet's delicate balance. Detecting heat miles beneath Antarctic ice required cutting-edge science and ingenuity. The challenge was immense. How do you study what lies hidden under miles of solid ice in one of the harshest environments on Earth? Scientists had to invent new methods and adapt existing technologies, pushing the boundaries of what was possible in polar research. They took to the skies, using specially equipped aircraft fitted with ice-penetrating radar to map the mysterious bedrock far below the surface. This technology allowed them to spot pockets of liquid water, clear signs of melting from below, invisible to the naked eye. These hidden lakes and rivers were a revelation, hinting at powerful forces at work beneath the ice. To unravel the mystery further, they combined radar data with precise measurements of magnetic fields, searching for anomalies that could indicate geothermal activity. Gravity measurements added another layer of insight, revealing geothermal hotspots by their unique signatures, areas where the Earth's heat was rising up through the crust. Seismic data, gathered from sensitive instruments, helped pinpoint the source of this heat. A mantle plume, a column of hot rock rising from deep within the Earth, similar to those that fuel volcanoes in places like Hawaii. This breakthrough explained the existence of vast subglacial lakes and rivers, hidden beneath the ice for millennia, and constantly reshaped by the warmth from below. Years of international collaboration, with scientists from around the world sharing expertise and resources, were essential to piecing together this complex puzzle. Advanced technology, from high-resolution sensors to powerful computers for data analysis, made this discovery possible and pushed the limits of what we can know about our planet. The process was like giving the continent a full-body scan, layer by layer, revealing a hidden engine of change that had been operating in secret for millions of years. The evidence is clear. Antarctica is not just a land of ice but also of fire, with geothermal energy shaping its landscape in ways we are only beginning to understand. This internal heat is now recognized as a major force shaping the continent's destiny, influencing everything from ice flow to the creation of unique ecosystems beneath the surface. The discovery is a testament to the power of modern science to reveal the unseen, and a reminder that even the most remote places on Earth hold secrets waiting to be uncovered. Deep beneath the frozen expanse of Thwaites Glacier, a powerful geothermal heat source is at work, hidden from view but shaping the fate of this colossal ice sheet. Thwaites is not just any glacier, it's one of the world's most vulnerable ice giants, often called the Doomsday Glacier, for its potential to dramatically raise global sea levels. The geothermal heat beneath Thwaites melts the glacier's base, creating a slick, lubricating layer of water. This hidden meltwater acts like oil on a slide, allowing the glacier to move faster and more unpredictably toward the sea. This process is invisible to the naked eye, but it's relentless, weakening the glacier from below, even as warming ocean currents attack its front edge, accelerating the melting from both sides. Recent scientific research using advanced sensors and drilling deep into the ice confirms that the combination of internal geothermal heat and external ocean warmth is pushing Thwaites ever closer to a tipping point. The glacier's surface is now riddled with cracks, crevasses, and deep fissures, clear signs that it's primed for rapid, large-scale movement. Even small increases in ocean temperature can have outsized effects because the glacier is already destabilized from beneath. The warm water seeps under the ice, compounding the damage. The hidden fire below is transforming Thwaites from a slow-moving block of ancient ice into a dynamic, unpredictable system, one that could change rapidly and with little warning. As internal meltwater builds and the glacier's structure weakens, massive chunks of ice break away, setting the stage for a potential catastrophic collapse. The fate of Thwaites is a stark warning to the world. What happens beneath the ice can be just as dangerous, if not more so, than what we see on the surface. As scientists and the world watch closely, Thwaites Glacier races toward the ocean, its future uncertain, but its impact on our planet potentially immense. Thwaites Glacier, known as the Doomsday Glacier, holds enough ice to raise global sea levels by over half a meter. If it collapses, cities like Miami and Shanghai could face catastrophic flooding. Thwaites acts as a dam, holding back the entire West Antarctic ice sheet. Its failure could trigger a chain reaction, unleashing even more ice and causing sea levels to rise by several meters. The timeline for collapse is uncertain, but the discovery of geothermal heat means it could happen sooner than expected. Every new study reveals the glacier is more fragile than we thought. The fate of Thwaites is a global issue, not just a polar one. Understanding its future is essential for planning and adapting to climate change. The world's coastlines depend on what happens to this single, distant glacier. Iceland is famous for harnessing geothermal energy. Its hot springs and volcanoes power homes and cities. In contrast, Antarctica's geothermal heat is locked beneath miles of ice, far from any population or infrastructure. Accessing this energy is an engineering challenge unlike any other. Unlike Iceland, Antarctica is protected by international treaties that prioritize science and conservation over resource extraction. The continent's harsh environment and lack of infrastructure make large-scale energy projects nearly impossible. Any attempt to tap this heat would face immense political, environmental, and logistical barriers. The goal in Antarctica is to preserve its pristine environment, not exploit it. While Iceland's geothermal power is a model for green energy, Antarctica's remains an untouchable curiosity. The contrast highlights how geography and policy shape our ability to use Earth's natural resources. For now, Antarctica's hidden heat is a scientific marvel, not an energy solution. Harnessing Antarctica's geothermal energy is nearly impossible with today's technology. Drilling through miles of ice and rock in extreme cold would be a massive, costly, and risky undertaking. The environmental risks are enormous, disturbing ancient ecosystems and potentially destabilizing the ice sheet itself. The Antarctic Treaty prohibits large-scale industrial activity, prioritizing research and preservation. There's no demand for large amounts of power on the continent, and transmitting energy elsewhere is unfeasible. Even supplying research stations is easier with wind, solar, and small-scale solutions. The risks and costs far outweigh any potential benefits. For now, the focus is on studying the geothermal heat, not exploiting it. Its true value lies in what it teaches us about our planet, not in powering our cities. The furnace beneath the ice will remain a scientific mystery for the foreseeable future. Melting Antarctic ice, driven by both climate change and geothermal heat, threatens the continent's unique wildlife. Sea ice is the foundation of the Antarctic food web, supporting algae, krill, and the animals that depend on them. As ice disappears, krill populations plummet, starving penguins, seals, and even whales. Scientists are already seeing declines in key species, with ripple effects throughout the ecosystem. Pollution is making things worse. Microplastics and soot from distant fires are reaching even these remote waters. Dark particles on the ice absorb more sunlight, accelerating melting. The combined pressures are pushing the Antarctic ecosystem toward a tipping point. This world, stable for millennia, is now changing too fast for many species to adapt. The loss of ice means the loss of an irreplaceable biological realm. The unraveling of Antarctica's ecosystem is a warning of what rapid change can do. While geothermal energy is out of reach, Antarctic research stations are leading the way in renewable energy. Many are switching to wind and solar power, cutting their reliance on fossil fuels. Solar panels work surprisingly well during the endless summer daylight, while wind turbines harness powerful Antarctic winds. These hybrid systems dramatically reduce emissions and the need to transport fuel. The British Antarctic Survey, for example, has slashed fossil fuel use at its stations with new solar arrays and batteries. These efforts make science more sustainable and set an example for clean energy in extreme environments. Antarctica's green transition is small in scale, but big in symbolism. It proves that even at the ends of the Earth, a cleaner energy future is possible. The discovery of geothermal heat beneath Antarctica opens a new chapter in climate science. It forces us to rethink how ice sheets melt and how quickly sea levels could rise. This knowledge is vital for predicting the future and preparing for climate impacts. While we can't tap this energy now, studying it could inspire new technologies and solutions. The Antarctic geothermal system is a challenge for science and engineering, pushing us to innovate. Continued exploration and international cooperation are essential. Antarctica's hidden energy reminds us how much we still have to learn about our planet. By unlocking these secrets, we gain insights that will shape our response to climate change. The fiery secret beneath the ice is a lesson for the future, one we can't afford to ignore.